Hi friends, my name is Mohammad Imran. Today we are going to discuss new launch program complex variable and the topic is analytic function. So let us start our topic from the definition. So analytic function definition is a single valued function which has a unique derivative at each and every point in the given region is called analytic function. So means that we can say if we have any function, there is a most important 2 points. One, that function should be a single valued, and second is it has a very unique derivative at each and every point of the given region. So we can clear our this analytic function by using a numerical problem. Suppose that, because we know very well about the analytic function is always having the two parts, one is the real and other is the imaginary part. So here in the numerical problem we are going to find out the analytic function when we have a real part. So let us start with the question. And the question is, find the analytic function when the real part is x square minus y square. There is a one important thing. If in your question this is given the real part, means that the real part is u. That's why in the solution we are taking, we have the real part as u is equal to x square minus y square. Now we know the Thomson formula, or you can say method, to find out the analytic function fz as f of z is equal to the integral of phi 1 z comma 0 minus iota phi 2 z comma 0 dz. Here the main thing is phi 1 and phi 2. So what are the phi 1 and phi 2? Here phi 1 is the partial derivative of the real part with respect to x. But thing is, here if you are going to differentiate partial derivative of u with respect to x, then it is not the phi 1 z comma 0. This is phi 1 x comma y, because u is a function of x and y. So to find out the phi 1 z comma 0, taking the partial derivative of u is equal to x square minus y square with respect to x. After taking the partial derivative, we are having phi 1 x y is equal to 2x. But my need is phi 1 z comma 0. That's why we are going to replace x by z and y by 0. So after replacing x is equal to z, y is equal to 0, we are having phi 1 z comma 0 as 2z, and the next step is to find phi 2 z comma 0. Again partially differentiate u with respect to y, and that is phi 2 xy is equal to minus of 2y. Again here my need is phi 2 z comma 0, but we have here phi 2 x comma y. So again there is a need to replace our x as by z and y by 0. So after replacing x is equal to z and y is equal to 0, we are getting phi 2 z comma 0 as 0. Now we have the both values of phi 1 and phi 2. So now this is the time to substitute, or you can say putting the values of phi 1 z comma 0 and phi 2 z comma 0 in the Thomson formula. So that was f of z is equal to integral of phi 1 z comma 0 minus iota phi 2 z comma 0 dz. But here after putting, we are getting here f of z is equal to integral of, and on the place of phi 1 z comma 0 we have 2z and phi 2 z comma 0 is 0. So after both the values we are getting this, and on after integrating we have f of z is equal to 2z square by 2 plus iota c. So finally we are having f of z is equal to z square plus iota c, which is our required analytic function. So this is the way to find out the analytic function of when we are having a real part of the function. Thank you.